4.6, using those congruent triangles. So we've just gone through many sets of notes and then that quiz, and we kind of concluded with there's 5 ways to prove triangles congruent. You can do side, 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 angle, side, HL for hypotenuse leg, AAS, angle, angle, side, or angle, side, angle, ASA. Those are the only 5 ways we can prove them, but those 5 ways are ways we can prove any set of triangles congruent. So if we can find that relationship, we can prove them congruent. So today we're going to use those congruent triangles to go one step further. So you're going to notice that the notes don't look like our normal notes, basically because after years of going through the old notes that the book made up, I found that kids just weren't getting what they needed to get out of this section, so I kind of just rewrote them myself to focus on what we need to do. So the key is right here, if triangles are congruent, so if we can use one of those 5 ways to prove them congruent, then all the rest of the parts of them are also going to be congruent. Okay, so once we say these 2 triangles are congruent, then any part we haven't marked can be proven congruent. Okay, so a couple things I want to go back over here to make sure that we're careful here. So what we're going to do is we're going to prove our triangles congruent. Okay, so 2 sets of congruent, and then we're going to prove the parts congruent. Okay, so that's kind of our goal here. Now there's a couple things that we need to watch when we do this. One is that you'll often see we're trying to prove some parts. That's what our job is, okay? Now, if you're like me in the last few sections, I always use the names of those triangles as a guide for how to name things and such. So what you're going to notice right now is they didn't name my triangles for me. It's not part of that prove. So we're going to have to be careful and figure out our names of our triangles ahead of time so we can be careful that we name things appropriately and in the right order. Okay, so that's one of the big things we're going to notice is we're not going to see those triangle names to start out with. Okay, mark up those pictures, and once again, I'll go way back to the very first day we talked about marking up pictures. Mark your givens. Never, ever, ever mark your prove. Only mark your givens, okay? So we're going to go ahead and we're going to make this plan. Okay, so let's mark our givens here. So we have angle Q is congruent to angle T. Okay, so angle Q is congruent to angle T, so they both get the same markings, okay? And QR right here is congruent to TR. So we're going to mark what we have. And then, as always, I always ask you, is there something else we can mark? So think about the things we often mark. Are there any shared sides? Are there any vertical angles? Are there any parallel lines which make some angles? Is there any vocab that we can mark? Okay, those are the things we're looking for. Is there something I can mark? All right, I agree with you. There's some vertical angles there, right? So we mark those vertical angles. All right, is that enough with what we marked to prove those triangles congruent? I would say, yeah, there's enough, right? So let's see. I'm going to prove, and now this is where we're going to be careful. We have to come up with these names ourselves. So remember, when we do this, you choose the first triangle. So over here on the left, I might call it QRP. Okay, so if I call the one on the left QRP, it needs to be congruent. Now look, Q had 1 mark in the corner, so that has to go with T down here. So triangle T. Okay, R was this double mark, and it's R on the other one too. So TR, and that leaves me with S. Okay, we're going to prove triangle QRP congruent to TRS by what reason? Okay, we're going to follow angle, side, angle, angle, side, angle. Okay, so we're going to prove those congruent by angle, side, angle. Then, once they're congruent, we know that our PR will be congruent to SR. So, once our triangles are congruent, then our parts are congruent, okay? And we need a reason for this. I did not just, okay, go up. There we go. Okay, and the reason we're going to use all the time after we prove our triangles congruent is this reason right over here, okay? Corresponding parts of congruent triangles are congruent. It's a long one, but think about it. The corresponding parts that go together of congruent triangles will have to be congruent, okay? Now, I will allow you to abbreviate some, but not all the way, so be careful here. So we're going to say then PR is congruent to SR by, and you see my abbreviation, corresponding parts of congruent triangles are congruent. Okay, so we kind of shortcut that. Okay, now what I just gave was the plan. Now we need to do the proof. Okay, remember you always have choices, right? You could do 2-column proof. You can do a paragraph proof. Don't forget, we now know how to do a flow proof. Your choice. Any one of the three is fine as long as the job gets done. All right. You're sticking to the 2-column. All right. Kind of boring, but we'll go with it. Okay, let's see if I give myself enough room here. I think I don't want to go too much further. I lose my givens. Okay. All right, let's get started here on our 2 columns. So my statement and reason obviously is kind of messed up. So I'll just start over here. I have angle Q congruent to angle T and QR congruent to TR. Okay, that's my given. All right, and that gives me a set of angles, and that gives me a set of sides. Okay, so what else do I need to throw in my recipe for angle, side, angle? Because that's the recipe I decided is going to work here, angle, side, angle. What else can I throw in to get my angle, side, angle? I have an angle, I have a side, I'm missing an angle. Okay, what did we mark in that picture for an angle that we need to put in our proof? You're right, those vertical angles. Okay, name the one on the left, and look, there's a lot going on at R. You cannot name that with one letter. You need to use 3. All right, so if on the left you want to call it QRP, angle QRP. Now be really careful, and if you need to, go back up to these names we figured out. Oh, look, it's right in order here. QRP will be TRS. Okay, I'm going to watch on every test and quiz for that order, so really watch that you follow that order. All right, QRP was congruent to TRS. One more reminder, why are those 2 angles congruent? Vertical angles, you're right, straight across from each other. Okay, so that gives me a pair of angles. Okay. My recipe called for 3 things. I put the 3 things in. What am I ready for? Triangles. All right, triangles. We already named them up there. QRP is congruent to triangle TRS, and the reason we said they were congruent was angle, side, angle. Remember, not so much what's in the proof order, but what's in the pictures order. Okay, we got that job done, so my triangles are congruent. So what do I do next? I'm going to prove those parts congruent, right? And just like I said, just like in my plan, I'm just going to go right for those parts, which was PR congruent to SR. And the reason is corresponding parts of congruent triangles are congruent. Okay? So if the triangles are congruent, then all their parts that go together are congruent. Okay? Not bad for the first one, right? Prove the triangles, then prove the parts. Let's go to page 2 and see how this one goes, okay? Just heads up, so you know, my pages may be different than your pages, but I had kind of spread them out so I had plenty of room on my board to do it. So if I say page 2 and it's not page 2, just go with me, okay? How about the next proof? Let's say that, okay? All right, let's see. They tell me on this one that CD is congruent to CB. And angle ACD, that's this one they marked in the bottom, is congruent to ACB, this one they marked in the bottom. Okay, so everything they have, they marked. That's good. What else can we mark? That shared side, right? Okay, so we mark that shared side. Is that enough to prove those triangles congruent? I would say yes, right? Goes side, then the angle, then the side. On the other triangle, side, then angle, then side. Yeah, I would agree with you. We can do that. All right, so they are, right? Okay, we need to come up with a name. So we're going to prove in our plan our triangle. On the left, do you want to call that DAC? All right, DAC. Don't mind me. All right, DAC is going to be congruent to triangle, let's see, D was the one not marked, to A that they share down to C, so BAC. And we said by what reason? Side, angle, side. Okay, so once we prove our triangles congruent, then we can prove angle D congruent to angle B by corresponding parts of congruent triangles congruent. Okay, we've got a plan. Let's make it work. All right, step 1. Let's go for that CD congruent to CB and angle ACD congruent to angle ACB, and those are given. All right, so that starts me out with a set of sides and a set of angles. Okay, so what's the next thing that we were able to mark, that we put into our picture? That shared side. I agree with you. Okay, so if we want to call it AC on the left, congruent to, let me see, AC on the left, AC on the, yeah, it looks like we can keep the order the same. AC on the right. And what's the reason for that? Looked in the mirror and saw itself, right? That was the reflexive property. All right, that's another set of sides. My recipe called for a side, an angle, and a side. Looks like I've got all three. I am ready for triangles. Triangle, what did we decide to call it? DAC, congruent to triangle BAC up there at the top. And the reason they're congruent is by side, angle, side. Now that my triangles are congruent, I can go ahead and prove my parts of my triangles congruent. So angle D will be congruent to angle B, and the reason is by corresponding parts of congruent triangles are congruent. Okay? Not bad. 3-step proof from before, we add one more step, and we're right where we want to be. Okay? Let's try our next one. Okay. Start off with AB is congruent to AC. They've marked it. Angle BAD, the bad angle, is congruent to the CAD angle up here. Looks like they're marked. What else can we mark? That shared side in the middle, right? Okay. So are those triangles congruent? Looks like it to me, right? Because we have a little bit of side, angle, side, or side, angle, side. All right. So let's make our plan. We're going to prove triangle. I kind of like that bad, right? That bad triangle congruent to the CAD triangle. Okay, and watch your orders. If you notice BA and I come down the D, then it's CA and I come down the D, right? So I follow that same pattern up the congruent sides to the one marked angle down the shared side. Okay, we're going to prove that by, what do we say? Side, angle, side. Then, okay, they want me to prove that AD down here, AD bisects this BC. So if it bisects, what would be equal? BD and CD. Okay, well, would BD and CD be part of those triangles? If we just prove the triangles by side, angle, side, then, oops, I don't want my highlighter left on. Then we could prove BD congruent to CD by corresponding parts of congruent triangles congruent. Then we can prove bisect. Okay, so we're going to use that vocab word there at the end. Okay, so the first one we start off with, AB is congruent to AC, that's a set of sides. It's given. Angle BAD is congruent to angle CAD, it's given. That's a pair of angles. AD is congruent to AD. Same thing, looks in the mirror, sees itself, that reflexive property. Notice how often it comes up here in Chapter 4. We were introduced to it in Chapter 2, didn't use it a lot, but we use it a lot here when we do these triangles. All right, so we're ready to say the bad triangle is congruent to the CAD triangle, and we already decided that was going to be by side, angle, side. BD is congruent to CD, we said by corresponding parts. The more we write this down, the more we remember it. Corresponding parts of congruent triangles are congruent. And if they are congruent, now we can say AD bisects BC. And when you see it, when you think vocab, that's right where it comes into. We just say definition of bisect. Okay, so if we bring in a vocab word, the reason is the definition of that vocab word. Okay. All right, let's do another example. That's the best way to learn these, is just example after example. Okay, that's really the best way and easiest way to kind of get used to this one. All right, another fill in the blank one, which is good. I can write my plan here. The question is how much of the plan I'm going to get to, right? Because this one definitely has some extra steps in it. All right, let's see. AB congruent to CD. Angle A congruent to angle D. AF congruent to DE. And we want to prove FC congruent to EB. All right, I'm thinking those triangles are probably going to be congruent, right? So if we prove, let's see, triangle. We can look down here if we want. They already named it for us, right? We can name, whoa, I'm slipping here. Okay, triangle FAC, that's the one on the bottom, right? FAC congruent to triangle EDB, the one on the top, by, what's it look like we're going to do? Side, angle, side, side, angle, side. Kind of. There's a little bit of work we're going to have to do there, but I think we can do it. By side, angle, side. Then FC can be congruent to EB by corresponding parts. Of congruent triangles congruent. All right. AF is congruent to DE, it's given. Angle A is congruent to angle D, given. AB is congruent to CD, given. Okay. We haven't seen this for a little bit. We have segment AB is congruent to segment CD, and we switch it to AB is equal to CD. We changed it from congruent to equal. What's our reason for that? Definition of congruent. Okay, anytime we switch from equal to congruent or congruent to equal, it's always definition of congruent. Okay. Next step says I'm going to add BC on the left, I'm going to add BC on the right. What do we call that if we do the same thing on both sides? Just what it is, addition, right? Just add. As long as it's the same thing on both sides, it's just add. The next step says AB plus BC. When we look up here, AB plus BC becomes the whole thing AC. CD plus the whole BC becomes the whole BD. They called it segment addition, part plus part equals whole. They did it a little bit different than we're used to. Then they went from equal to congruent here. That should have a congruent mark right in there. By definition of congruent. Okay. So this was a pair of sides, the whole thing, AF and DE. This was a set of angles, okay? Until we named AC from here to here and BD from here to here, this is the first we actually have our third piece, right? Our full set of sides. So now my triangles are congruent by side, angle, side. And if my triangles are congruent by side, angle, side, then my parts, FC, is congruent to EC by my corresponding parts. Of congruent triangles are congruent. Okay. All right, so again, prove your triangles, then you can prove the parts. Okay, those were our easier ones. I have two relatively harder ones to finish out the notes here as a good example and to show you kind of where some of this leads to. All right, lots of things going on here, lots of lines and triangles. Let's get some things marked. Okay, starting out, they say NO. Where is NO? NO is over here. Is congruent to PM over here. Angle 1 up here is congruent to angle 2 up here. And OR down here is congruent to MR. All of those are given. That's good. All right. Our job is to prove triangle OQR and triangle MQR down here in the bottom congruent. Okay? Is there anything else we can mark? We can mark that shared side in the middle. Those are definitely congruent. Okay? What else do we know about those yellow triangles? Remember, there's a third angle rule that if two sets of angles are congruent, then the third set of angles is congruent. But there's no such thing as a third side rule. So if two sets of sides are congruent, that doesn't tell us anything about the third set, so we can't do that. All right, I'm hearing this right now. What if we come up to the top triangles? This triangle and this triangle, okay? They already have a set of sides. They already have a set of angles. What else can we mark in just those triangles? The big X, right? The vertical angles, okay? Will that prove those triangles congruent? It will, by angle, angle, side, angle, angle, side. If those triangles are congruent, how can they help us with the yellow triangles? You're right, they have parts that they share. So if we could say QO and QM are congruent, then we'd have enough stuff for our yellow triangles to prove those congruent. Okay, so we're kind of getting a pattern here, a plan. Okay, so the first thing we're going to do is we're going to prove on the left side there. Let's see, triangle NQO. Congruent to triangle. Okay, NQO went from the one to the middle where they shared out to the outside. So it's going to be P at the top to Q to M, PQM. So we're going to prove that by, what do we say? Angle, angle, side. The side's not between the angles, so we get the angle, angle, side. Then, let's see, what parts do we want to use from there? We want to use the shared line between the yellow and the blue triangles there. I'm just having a good time tonight hitting different things, aren't I? QO, congruent to QM, and that will be by corresponding parts of congruent triangles congruent. All right, then we can prove our OQR congruent to MQR, and that will be by side, side, side. All right, we've got a plan. Let's go ahead and make it work. All right, first things first. I'm not going to use all my givens at first because I want to stick to the blue triangles first. That's the first part of my plan. So NO and PM, that was definitely part of them. NO, PM, that's part aside on that top one. And angle 1 and angle 2. Those were an angle in the top one. Those are given to me. All right, what else did I mark in the top triangles? Well, we mark those vertical angles. There's a lot going on there, so 3 letters are necessary. How about NQO on the left, congruent to PQM on the right? Why are those angles congruent? They're formed by that X, so we definitely get those vertical angles. All right, let's see, side, an angle, and an angle. I think that's enough pieces in my top recipe for my top triangles, so I can go ahead on those top triangles. Triangle NQO on top, congruent to triangle PQM on top. And again, don't look in our proof because that order can be mixed up, but look in our picture. And in our picture, we had an angle, side, angle, side, angle, angle, side. So we're going to do angle, angle, side. Okay. Now that the triangles are congruent, we can prove their parts, which is going to be QO, congruent to QM. Okay, we can now mark these, right? And the reason for that is corresponding parts of congruent triangles congruent. Okay, a set of sides on those bottom ones. Okay, let's go back to the rest of the bottom. Don't forget, we haven't used all our givens. We still have that OR up there, congruent to MR, because it was in the bottom triangle. And that was given. So that's a second pair of sides. What else did we choose to mark there? That shared side, right? QR, congruent to, I check my name up here, QR and QR. Yep, they're going in the same direction. So QR and QR by reflexive, when you look in the mirror and see yourself. And that's a set of sides. So on my bottom triangle now, I have 3 sets of sides proven congruent. So I am ready for my triangles. And it looks like it's the final ones, OQR, congruent to triangle MQR. And the reason is side, side, side. So I had to use my earlier triangles so that I could get enough pieces on my new triangles to prove them congruent, okay? So this is really where we kind of see what's going on here and what we're trying to do, okay? Let's move on to that final one, all right? And we're going to try to work through these. Lots of triangles showing up here, so we're really going to have to focus on what we can see and what we can work with, okay? I have a BC congruent to DA, so BC and DA there. I have angle 1 up here, congruent to angle 2 up here. I have CF, now be careful, that's a big one there, congruent to AF, so it goes all the way down to the bottom. And our final job is to prove triangle CFE, that's this one over here, congruent to AFE, which is this one here. Okay? So those yellow triangles are what we're trying to prove congruent. So we have one set of sides on those yellow triangles. That angle 2 and the sides over here, these are, oops, didn't want to highlight that. I wanted to just mark it with a green pen. I didn't have the green pen. There we go. These sides over here, that's not part of the yellow triangle, and neither is angle 1 or 2. What else can I mark on the yellow triangle? Yes, the shared sides. It's only 2 things, though. Be careful, I don't have, on the yellow triangles, this angle, let me see where we're going. I see some vertical angles. Okay, I see an X, but look here. That's not really touching the yellow triangles because it didn't go all the way to the side on the yellow. Ah, somebody said, but it does hit a different set. Okay, let me see if I can do a highlight here to make this a little more obvious. So this angle was formed by this line, and we can finish out that triangle. This one was here and here. Can't even trace my lines well. Are those 2 triangles congruent? I do have 3 things marked. I have an angle, angle, side, angle, angle, side. If I mark those congruent, do they have a part that will help me with my big yellow ones? Yeah, how about this side and this side? If we can get those 2 congruent, then that'll help me with my yellow ones. I like it. Let's go for it. Okay, so we're starting in the blue triangles, right? So our plan, we're going to prove my blue triangle at the left. I'm going to call it CBE. And I'm going to prove it triangle congruent to CBE. How about ADAE? And the reason is angle, angle, side. Then we want parts, I was pointing to them with the arrow there, CE congruent to AE by corresponding parts of congruent triangles congruent. Okay. Then we can prove our triangle CFE congruent to triangle AFE by side, side, side. All right, we've got a few steps. Let's do it. Okay, starting off, we're going to go with the blue triangles. Let's only pick up pieces that go to the blue triangles and put those in the proof first, okay? So it looks like my BC and my DA, those were good. Congruent to DA. So we use that one, right? And you're right, angle 1 is congruent to angle 2. That's also on that first one, on the blue triangle, right? And those were given. That's 1 pair of sides, 1 pair of angles. Okay, what else did we mark on those blue triangles? The vertical angles. Lots going on there by E. Make sure we use 3 letters. So from the left, how about BEC? So from the right, that's going to be DEA. And the reason we could mark those angles, that full X, right? So it gave us vertical angles straight across from each other. All right, I have a side, an angle, and an angle. It's not about how the order in the proof, it's about the order in the picture. How are those blue triangles congruent? Well, we're going to call those blue triangles, if we look up at our plan, CBE and ADE. And they are congruent by, if we look in our picture, side, nope, side, angle, angle, or angle, angle, side. You can call it either one. I wouldn't mark it wrong. Angle, angle, side. All right, now what piece do we want off of those triangles? We want what I'm pointing to with my arrows there. CE congruent to AE, just like in our plan. And the reason is corresponding parts of congruent triangles are congruent. All right, we're on to the yellow triangles already. So that was a set of sides on the yellow triangles. What else for the yellow triangles? Don't forget we had this given up here we haven't used yet. CF congruent to AF. That was a given. That's a pair of sides. And we also marked what in there? Oops. Ah, the shared side, right? FE congruent to FE. And when you look in your mirror, you see yourself, that is reflexive. And it's the exact same thing on both sides. And that's a pair of sides. All right, that means that we are ready. Does my paper move any? No? All right, I guess we'll put our last step over here on the left. My last step, because I have three sides, I am ready to say triangle CFE is congruent to triangle AFE, and the reason is side, side, side. Okay? Find a plan and go through it and make sure you prove the first triangle, then the parts you need off of it. And in this case, then keep going for the rest of the parts of the second triangle. Okay? So the key is prove a set of triangles congruent and then the parts you want off of those triangles. Okay? I have one more hint I want to give you as you go into your homework sheet. Okay? You do have a worksheet for this, and especially like number 9 on your worksheet. Okay? It gives you a bunch of coordinates, and it says use these 6 coordinates to prove that your angles A and D are congruent. Well, how in the world do you use coordinates on a coordinate plane to prove angles congruent? Probably aren't going to prove them congruent just by coordinates, but what can coordinates prove? Or what can we do with the coordinates? I like the way you're thinking. I like distance formulas too, right? How about some distance formulas? Okay. How many are you going to need to do here? 6. Okay. So think about this. Our plan is we're going to prove triangle ABC congruent to triangle DEF. So as a quick hint, you want AB to match with DE. You want BC to match with EF. What's the third set of sides on the first triangle? Ah, that jump from front to back, right? Or back to front. CA congruent to FD, right? There's your 6 sides you want the distance formula for. Quick question. Should they match up? Yeah. So you're going to prove these triangles congruent by side, side, side. That's after you do the distance formulas. That's going to prove the side, side, side. Then you can say angle A is congruent to angle D by corresponding parts of congruent triangles are congruent. Okay? So you don't have to do a full proof for this, okay? I don't need to see a 2-column proof. What I need to see is 6 distance formulas. You say the triangles are congruent by side, 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 and then you tell me the angles are congruent by corresponding parts of congruent triangles congruent, okay? If this was on the test, when it's on the test, you're going to prove triangles. Wait, let's start here. You're going to do 6 distance formulas. There's 6 points. You're going to prove the triangles. There's a point by side, 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 okay? And then you're going to prove triangles by corresponding parts. There's a point. So this would be an 8-point question on a review guide or on a test, okay? So make sure you do the work for that. Don't shortcut me. When I look at those pictures, I'm going to be looking for all those distance formulas, okay? Practice it. The best way to get good at anything is to practice. If you have questions, let me know. Send me an email. Ask me. Maybe we need to do more together. Good luck.